Hey everyone, let's take a look at number 7 in section 4.2. We're going to find all critical points of this function for the values of x strictly between -1 and 1. Now, some of you might have the sine inverse function. So this is the cosine inverse function or arc cosine function. It is not this is not an exponent. This is not cosine of x to the -1 power, which by the way would be secant of x, right? Secant of x is the reciprocal of cosine. This is the arc cosine function. So you do need to remember the derivative for the inverse trig functions. Now the normal domain for the arc cosine function is all real numbers from -1 to +1, because that's the range of the cosine function. Notice though, they're excluding the endpoints essentially in this. Okay, so I'll mention that here in a second, the importance of that. So we are to find critical points for this function just strictly between -1 and 1. Okay, you do need to be familiar with the derivatives. Some of you might have the arc sine function or sine inverse function, and that derivative is this, right? The derivative of the arc cosine function is very similar, just -1 times that same expression. So again, I showed you how to derive these using implicit differentiation. Make sure that you are familiar with that so you can remember that, as well as the derivative of the arc cosine function as well. Okay, so let's find the derivative of this function in order to find the critical points, right? So the derivative of the arc cosine function is -1 divided by the square root of 1 minus x squared, and the derivative of 8x is easy as 8. So the critical points, remember, are where the derivative is either 0 or undefined. Now you'll notice that the derivative is undefined when x is either positive or -1, right? Because you would be dividing by 0 here. But these are the endpoints, and notice we're excluding those values. So while if we had played on the entire, or had set the entire domain, or let the domain be everything from -1 to 1, technically 1 and -1 would be critical points. But because of this, they're forcing you to just give any critical points in between that, so not including the endpoints. And what's happening at the endpoints are basically we're approaching a vertical tangent line at each of those endpoints. Okay, so we don't have to worry about when it's undefined, because it's always defined for values strictly between -1 and 1, but when is it equal to 0? Well, this sum will be equal to 0 if the square root of 1 divided by, 1 divided by the square root of 1 minus x squared is equal to 8, right? If this is 8, then this would be -8 plus 8, which is 0. So now you just need to solve this equation. To get rid of the square root here, I could square both sides, right? If I square that, I just have 1 over the quantity 1 minus x squared. Of course, 8 squared is 64. And then I can multiply both sides by 1 minus x squared to get rid of that fraction. Distribute the 64 through, subtract 64, and then divide by -64. A negative divided by negative is a positive. And I can take then the square root. Make sure you remember to include both the positive and negative roots. So these are the values of x where the derivative is 0. Hence, and also, by the way, the numbers are between -1 and 1, right? Which was that domain restriction we had. So this is these are the critical points. Now we can simplify these a little bit, because the square root of 63 divided by 64 can be written this way. Of course, the square root of 64 is 8, and 63 can be the square root of 63 can be simplified because there is a perfect square factor of 63, and that is 9. In fact, 9 is the largest perfect square factor of 63. So you should remember how to do that sort of simplification. The square root of 9 is 3 times the square root of 7. So this is the value, and therefore plus or minus this quantity are the critical points. Make sure you follow the directions in Achieve. They do want you to list comma separated lists, so they don't want the plus or minus. You would have to list one as positive that, comma, negative that. Okay, hope this is helpful on this one.